So, welcome back to a new external topic, Level 2 physicists looking at electronic systems, and today we will start with looking at static electricity. Okay, so in the description for this video, I've added two links to PhET simulations. Okay, the first one is the balloon sweater simulation, and if you use that, you'll see that when the balloon rubs against the sweater, electrons transfer from the sweater to the balloon. And the reason why that's happening is that the protons and neutrons are buried deep inside the nucleus, okay, so they can't really be pulled away. Whereas the electrons are orbiting, it's a weaker electrostatic force between the nucleus and the electrons. So electrons are easier to be lost and to be gained, which is basically the principles around static electricity. And the second simulation that I added in the description is the John Travoltage simulation from PhET. And if you rub John Travoltage's foot against the rug, what you will see is that John Travoltage will gain electrons, and then when he touches the conductor, he'll get electrocuted as it completes the circuit. And that's caused by friction. So another way that objects can be charged is through contact. Okay, so here we have a charged rod, which is negative. It's then going to touch a neutral insulator, and you'll see that the charge gets transferred. So the insulator becomes now negative afterwards, goes from 0 charge to -3 charge. And the final way is through induction. Okay, and what happens there is, say, for example, an electrical storm. The negative electrons in the cloud get kind of attracted towards one end of the cloud, okay, and what happens is that then these electrons transfer into the tree because the positive charges also get attracted up from the earth into the tree, and that's why we have lightning strikes as the electrons move from the cloud into now the positive tree. And what's happening to these people while their hair is standing up? Well, what's happening is their hair is becoming positively charged, just like the tree. And what's happening is the different hairs are then repelling each other because like charges, as we will see, repel each other. So why does this happen? Why does induction occur? So this is how you would induce charged electricity into an aluminium pie plate. So you've got a fur rubbing cloth. Okay, you rub it against an insulator or foam plate. So that means that the electrons from the fur get transferred into the insulator, the foam plate. And then what happens is you bring a aluminium plate towards the foam plate, and the positive charges begin to move down. And then you touch it, the plate, and the electrons get taken into your hand. So now you've got a positive plate and aluminium plate and a negative foam plate, and now you've actually induced charge difference. Okay, so there you go. Be sure to note this information very carefully. So just reviewing charges, so opposite charges, plus and minus, attract, and like charges, like positive and negative, repel. Okay, and the important thing there to know is that the total charge is in coulombs. Okay, so the units of charge are coulombs. The symbol is Q, and they relate to the number of electrons. Okay, so an electron has a charge of 1.6 times 10 to the negative 19 coulombs. Not much. Okay, so when you're dealing with static electricity, you're dealing with those kind of small numbers, so you have to get used to your metric prefixes. So, for example, milli is times 10 to the negative 3 in terms of charge, or coulombs, micro times 10 to the negative 6, nano times 10 to the negative 9, and pico times 10 to the negative 12. Okay, so next lesson we'll look more at the electrical fields that form from these charge differentials.